right, so today we are going to do just a brief review of solving quadratic equations. And we're going to start by looking at some kind of generic guidelines that you want to follow when solving a quadratic. So the first thing we want to do is write it in descending order. So you're going to be given some equation. We want to write the equation in descending order, and we do that according to the exponents. And we want it set equal to 0. Which means you're going to end up with something of the form ax squared plus bx plus c equals 0. Keeping in mind that a, b, and c are not always positive numbers. They could be negative values, but they will be integers of some sort. All right, the second step that we want to take, once we have it set equal to 0 and in descending order, is to factor out any greatest common factor if one exists. So factor out a greatest common factor. There will not always be a greatest common factor. So here we're going to put if possible. And we'll look at examples where no common factor exists and other examples where there most definitely is a common factor. The third step that I take, once I have that value factored out, I like to divide both sides by the GCF, if there is one. What that's going to do is simplify some of the process in terms of the parts that are going to come after this. And the greatest common factor, typically referred to as the GCF, like we said, if possible. Since there won't always be a GCF, these two steps, steps 2 and steps 3, will just be dependent upon what the problem itself says as to whether that exists or not. All right, 4, we want to factor in some form. That may be factoring into the difference of two squares. It may be factoring a trinomial, something with 3 terms, like this is a trinomial. Factoring it into 2 binomials. It could be any number of things, but ultimately, we need to factor it somehow. And then once we have it factored, in step 5, then we're going to set each factor equal to 0. And solve. And we'll talk about why that's useful as we kind of work through an example. So like I said, these are very generic descriptions of the process that we're going to be following, but it is the same process every time. All right, so let's look at our first example then. We have x squared plus 10x equals 144. Now on the left side, we already have it in descending order, the exponents decreasing from an exponent of 2 to an exponent of 1. But we do need to get it set equal to 0. So to do that, we're going to subtract 144 from both sides. What that's going to do on this side, we want to leave the quadratic term, the term with the exponent of 2 at the front. Then descending order tells us the single x term goes next, and the constant, the negative 144, is going to follow that. On the right side, we end up with 0. All right, so the second step is to look for a GCF. In this case, the only factor that would have in common, because the lead coefficient is a 1, the only value that these 3 numbers, 1, 10, and negative 144, have in common would be a 1. When that happens, don't worry about doing step 2 or step 3. All right, so the next thing we want to do is factor it. And when we factor it, we're looking to determine if this trinomial can be broken apart into 2 binomials, 2 things each having 2 terms. where when multiplied together, it produces this quadratic here. So if I think about the first term, and remember with a binomial, I'm going to use my pencil over here if I can get a hold of it. With the binomial, it's going to have some term here and some term here with either a plus or a minus in between. And likewise, we'll have the same on this side. Two terms with a plus or a minus in between. Now, if I think about foiling or multiplying two binomials, we take the first term in each case and multiply them together, and those should produce the first term here. So in order for that to happen, for the first terms to have a product of x squared, then both of those terms must be x. So given that, I'm going to go ahead and substitute those in. Now let's consider the last term in each case. If I multiply these two last terms together, it should give me a value of the last term here, excuse me, negative 144. Now if I think about what it takes for two numbers to multiply together to produce a negative 144, the only way that can happen is if one number is positive and the other is negative. If they're both positive, then when multiplied together, I get a positive result. If they're both negative, negative times a negative would make a positive result. So the only way I can get a negative here is if one of these factors is a plus and the other is a minus. All right, so aside from determining plus and minus from this term, I also need to kind of keep in mind something else. There are many numbers that have a product of 144. For example, we could do 1 and 144. We could do 2 and 72. Let's see, 144 divided by 3 is 48. 4, 36. So the question becomes, how do I know which of these many terms, or many pairs of factors rather, how do I determine which one is going to be the correct one for the problem that I'm on? So I'm going to go ahead and write some more of these down. And there are others. We could go up to 12 times 12. 144 divided by 9 is 16. 10 won't work, 11 won't work, but 12 times 12 does. And that's where it's going to start repeating, because then I'm going to get to 16 times 9 and 18 times 8 and so forth. All right, so let's think about what's going to happen. When we multiply two binomials, we take first term times first term. That gives us the first term here. Then we take outsides, which is going to give me some number times x. And the inside is going to give me some number times x. Those two together, the outsides and the insides, have to produce a positive 10, which means I need two numbers that multiply to give me 144 and that have a difference, because these two signs are different, they have a difference of 10. So in this list, I'm looking for two numbers. These all have products of 144, but I'm looking for two that have a difference of 10, and that's where we get to this pair. Now, how do I determine whether to put the 8 here or to put the 8 here? That's where this middle term comes into play. Not only does it tell me what difference there has to be, but it also tells me the bigger number has to be positive in order for this to be a positive result. So I want the positive 18 and a negative 8. And if we were to check that, we can see that it's going to give us the values that we need. So in terms of our check, first term times first term would be x squared. Outside, x times negative 8 is negative 8x. Inside, positive 18x. Last, negative 144. And we can see that these two middle terms, the second term and the third term, are going to, when added, combine together to give me a positive 10, which tells me I have all the correct elements in the correct position. Okay, so let's consider for a minute what's actually going on here, and this is what's going to explain why number 5 works the way it does. We have two quantities being multiplied together, and their product is 0. Now, if you think about multiplication, the only way that a product can be 0 is if one of these quantities equals 0. So in that case, either x plus 18 equals 0, or x minus 8 equals 0. Which means there are two possible numbers that can make this equation true. Now, it says set each factor equal to 0, which is what we've done, and solve. So I'm going to solve for x in this case. To get x by itself means subtracting 18 on both sides. And this one means adding 8 to both sides. And we get these two solutions. Now you want to go back and check them in the original equation and make sure they work. So if I do my check in this case, if I take negative 18 and square it, be cautious of how you type that into your calculator because a negative squared should be a positive, plus 10 times negative 18, I'm looking, does it actually produce 144? So negative 18 squared gives us 324. 10 times negative 18 is a negative 180, which does give us, in fact, 144. So that one checks out correctly. Now let's try the 8. We take 8 squared plus 10 times 8. So 64 plus 80 is 144. So in this case, both solutions work, which means they are both answers or solutions to this particular quadratic equation. Kind of ran that off the bottom of the screen. Sorry about that. All right, now let's look at number 2. Actually, take a minute, pause the video, work this one out on your own, and then come back and check it. All right, so assuming you've done that, we've got it in descending order on the left, but it is not set equal to 0. So we start by subtracting 40 on both sides, which in this case is going to produce x squared minus 2x minus 48 equals 0. There is no GCF because the lead coefficient is 1, so that allows us to skip steps 2 and 3 above. 4, factor. All right, for the first term to be x squared, both quantities must start with x. For the last term to be a negative, one must be positive, the other must be negative. So I need two numbers that have a product of 48 and a difference of 2. So two numbers that multiply to give me 48, 8 and 6 have a difference of 2. Because this is a negative 2, the larger number 8 has to go with the negative. So this is 8, this is 6. And there again, we can check that if we need to. First times first, x squared, outside negative 8x, inside positive 6x, last negative 48. Now for those of you that aren't recalling, remember we're using FOIL in that case. First, outside, inside, last. All right, so let's just check. There's our x squared. These combined give me a negative 2x, and there's our negative 48. All right, once we have it factored, then we set each factor equal to 0, because how else is the product supposed to be 0 unless one of the factors or both are 0? All right, solving each of them then, I get x equals negative 6 or x equals 8. All right, let's check it, make sure it works. You have to check each solution independently. So I'm substituting into the left side and determining if it equals 40 as it should. Negative 6 squared minus 2 times negative 6 minus 8. So negative 6 squared, remember to be cautious about how you type that into your calculator. We get a value of 40. So that one checks out. Now we check the 8. So 8 squared minus 2 times 8 minus 8 is 64 minus 16 minus 8, 40. Both solutions work. So there are two solutions to this equation.